So in this question here, we've got a situation where a person called Nell throws a ball at a 60-degree angle at a speed of 14 meters per second from 1.8 meters high. And that's what's described in this diagram here. So a person throwing a ball with all the information on there, and this is the angle at 60 degrees, 14 meters per second. Now Maya the dog sets off a fifth of a second after they've released the ball, and then catches the ball some distance along, and the dog catches it at 0.3 of a meter off the ground, 30 centimeters off the ground. Now if the dog accelerates with constant acceleration, we need to calculate that acceleration for when it catches the ball. So how are we going to do that? Well, we need to find the acceleration along this distance here, but we don't know how far it is at the moment. So that's going to make it tricky to solve using our kinematic equations or SUVAT equations. So let's have a look at what happens with the ball first, because that's what the dog is catching. So we've got two separate things going on here. Acceleration for the dog, but we can work something out with the ball here. Now the ball, as it's being thrown up in this direction, it's got two components to it. It's got the vertical component and the horizontal component. So let me do a little bit of calculating on here. So the vertical and the horizontal. Now for the vertical, that's the force going up. Now what we can do is we can use that because we've got the speed, we've got the angle with which it's thrown at, and we can maybe use something in that because we know the gravity acting on it is 9.8 meters per second squared. So gravity equals 9.8 meters per second squared. So with all that information, maybe we can find some solution. So let's write our values in here for the SUVAT. Okay, now the distance we don't know. Initial velocity we know is 14 meters per second, but it's at an angle. So we need to work out what the vertical component of that velocity is. So if we draw a triangle, try and represent that. 14, it represents the angle at the 60-degree angle. So this angle here is 60 degrees. This is a right angle. So the vertical component is this one. This one is opposite the 60-degree angle. So I'll just call that O. Let's call it OP. So this angle here, from trigonometry, we know if you use sine of 60 and this opposite with the hypotenuse, we can solve for this side. So we know that sine equals opposite over hypotenuse. So here our angle is 60. So sine of 60 equals opposite over 14, which is our hypotenuse. Sine of 60, we know that is root 3 over 2. So we've got root 3 over 2 equals opposite, let's put the p next to it, opposite over 14, multiply both sides by 14, so we'll have 14 over 2, which is 7, so opposite equals 7 root 3. So therefore our vertical component of our speed is 7 root 3. So that's the initial velocity. Okay, now the velocity as it's in the air, we don't know too much about. Acceleration as it's going up, well, that's going to be the force of gravity in the opposite direction, because gravity acts in this direction, but the ball is going in the upward direction. So we've got minus 9.8. And t, what is t? Well, we don't know what time is. Maybe we can work out the time that the ball is in the air. That way then we can work out something for the length as the ball is travelling in the horizontal direction. So time is something we need to work out. Now in the horizontal motion, we've got this one here, displacement. We don't know much about it at the moment, but let's have a think about it. The ball is released from 1.8 meters high. As it goes up, as it's going along this distance here, we don't know how high it reaches, but that's not really important. What we do know is when it lands in the dog's mouth, it's 30 centimeters off the ground. So in the vertical component, it's actually lost 1.5 meters of height. So displacement is minus 1.5. So with those values, we can use S, U, A and T. So there's an equation of the SUVAC equations that we can use. S equals UT plus a half AT squared. So plug those values in that we know. So S equals minus 1.5. U is 7 root 3. And then we've got acceleration is minus 9.8 divided by 2, basically. So we've got minus 4.9. So change that to minus 4.9, and that's t squared. So now we've got t squared, t, and a constant. So this is looking like a quadratic kind of question. So we'll have two solutions. So let's write this as a quadratic and set it to 0. So we've got 4.9 t squared. Bring this over here, minus 7 root 3 t, minus 1.5, and that equals 0. So with that, if we put that in to our calculators and solve it, we'll get two values for t. Now one value, t is going to be less than 0. That's not of any interest to us. We don't want to know what happened before we threw the ball. But what we're interested in is how long the ball travelled to get to here. So that'll be the other value. So with the calculations that they got, with that we'll get t is approximately 2.592 seconds. So that takes care of that. So that's the vertical component. So that's all good. So I'm happy with that. So now what about a horizontal? Now as the ball travels, what do we know? Well, let's put our values for SUVAT up here again. Now for the ball travelling, the horizontal component will be on from our triangle here. So now if we look at this one as the adjacent, just leave that as A, we can use cosine. So cosine equals adjacent over hypotenuse. So cosine of 60 equals adjacent over 14. That's what we've got. Cosine of 60 we know is a half. Times both sides by 14, we'll get the adjacent equals 7. Okay, so that's 7. So that's the speed as it's going along the horizontal. But that's the speed of the ball. What we're interested in is what happens with the dog. So what can we do to manipulate that in there? Well, let's work it out. So speed is 7. So the ball, so for the ball, horizontal speed equals 7 meters per second. So that's what we've got. But now let's have a look in terms of what happens with the dog, because this one here is with terms of the ball. We want to know with the dog because that's the acceleration we need. So acceleration is what we want to find. Now time, we can work it out because it took the ball 2.592 seconds. So the time that was there, 2.592. But the dog had a fifth of a second disadvantage. So if we take 0.2 off the total time, we'll get 2.392. So that's 2.392. Now the velocity of the dog, we don't really know anything about that. But we do know its initial speed, because when it took off, it was stationary. So speed of the initial speed was 0. Now displacement, how far did it go across? Well, we got some idea what we could do there, because for the ball travelling at 7 meters per second for 2.592 seconds, the displacement for the ball for the ball is S equals 2.592 times 7. So that's going to give me 18.144 if I put that in a calculator. So that's the distance that the ball travelled. Now, if the ball travelled that distance, then so did the dog. So S equals 18.144. So So now we're back to where we was on this previous one, where we've got one missing, and we could use this equation again. So let's keep these bits separate. So S equals ut plus a half at squared. Well, S is 18.144. Initial velocity is 0, so we can discount that. So that equals a half times time squared. Well, it's 2.392 in terms of the dog. 2.392 squared. And acceleration is what we need to find. So multiply all that by acceleration. So now let's plug that into a calculator and divide by 2. We'll get 2.861 approximately. So 18.144 equals 2.861 times A. So now to get the acceleration of the dog on its own, just divide both sides by that. So A equals 18.144 divided by 2.861. Now, just to be correct, these are approximations. So I'm going to put a little curly equal sign there. So 18.144 divided by 2.861, we're going to get approximately 6.3. So the dog accelerated at 6.3 meters per second. So acceleration equals 6.3 meters per second squared, and I'll call that to two significant figures. And that is our answer. Okay.